Hello and welcome back to the Tower Defense series. Today we'll be getting some basic AI set up and get it running, and instead of making them follow a simple line, we'll be using the Astar algorithm to give them slightly smarter pathfinding. This in the future will allow us to generate and place things like special roadblock towers and more, and they'll actually kind of figure it out themselves and try and find the correct path to the target that they want to go for, which in our case is the enemy base. You can learn a lot from actually learning and using the A-star algorithm, and I kind of decided that A-star would be the better approach for this, purely because it is far more applicable in the future for different projects, and it is just a good thing to learn. So, let's just kind of start by getting our little enemy set up and running, right? One of the things we need to do for this is actually make sure we have assets for our enemy, which we don't actually have currently. So if we remember correctly, we right-click on our res folder, open File Manager, and we have a downloads file here, tower defense assets. We can go into the PNG file on the default size, and we can look for the enemy to use. We're going to use this little guy right here, tower defense tile E246, little red and grey character. What I'm going to do is I'm going to right click and I'm going to cut. We'll go back to the tower defense tutorial, under assets, under tiles, and I'm just going to paste it in there for now. Now with our sprite actually in the game, let's go and create our enemy scene. So to do that, we're going to add a new scene. This is going to be a character body, so all of our towers, well, not all of our towers, all of our enemies will be character bodies. I'm going to name this enemy entity. I'm going to hit Control S, I'm going to save that under scenes, main, under new, and I'm going to call this enemy. Now with that done, we actually need to add some things to our scene, right? We need to make sure we have a sprite 2D, and we're going to need to make sure we have a collision shape 2D. And we can just give this a little circle shape. We can drag our sprite onto the sprite 2D here. Make sure things are lined up correctly, and they are. That collision looks fine, and the sprite looks fine as well. I'm going to hit Control S and save, and we are going to add a script to the enemy entity here. Now, let's go and give this a class underscore name, because the class for enemy entity will be very, very useful in the future. And we need to think about what we're actually going to be needing to use on this, right, variables wise. So we know we're going to want to have a exported var for movement underscore speed. I'm going to call that a flow and set it equal to, we'll say 200 for now. We're going to need an at export var target, right? Because we're going to need to know what our target is. Now, a lot of this we will be changing in the future and making it so it kind of handles itself programmatically rather than us setting up exports and things. So just for now, keep that in mind. We're going to just make this a marker 2D for testing purposes. I'll set that equal to null. And we're going to be needing a few extra things to kind of get this running. But before we actually carry on with that, let's start setting up the pathfinding before we start using it on the character, right? We need to actually design the thing before we call it. So let's hit Control S and save. And we're going to create a new scene. This is going to be an other node, and it's going to be a basic node type. Now, I'm going to rename this to the Pathfinding Manager. I'm going to hit Control S and save, and I'm going to save this under the managers folder that we have created. And I'm going to add a new script to it. Now, once again, this is a class name we will need to make use of. So we give it one for Pathfinding Manager. We do not need the ready or process functions, as I pressed the wrong button there multiple times. So for this, we're going to need access to the tile map, right? So to build an A-star grid, you actually need access to, well, it's nice to have access to the actual tile map you're using so you can programmatically build the grid other than set, so you don't have to set in hard-coded numbers. So in this instance, what we can do here is just do an export var for the tile underscore map underscore grid of tile map layer, and we set that equal to null. That now gives us the ability to use anything that's under the tile map layer, and we're going to need to set up the A-star grid and a few other things. So A-star grid, all we want to do is write var A-star underscore grid of type A-star grid 2D, and we set that equal to a new A-star grid 2D. So astargrid2d.new. We're more or less ready to go. Now, A-star grids work based off of a fun algorithm that I can't really explain too well. I will probably put like a link as for a description. Actually, even better, I can do this. Aha! A-star grid is a variant of A-star 2D. There we go. An implementation of the A-star algorithm used to find the shortest path between two vertices on a connected graph in 2D space. So, that basically means, if we have 3 squares, or if we have a 3x3 square and we want to go from 0, 0 to 3, 3, it will find the fastest path based on a movement cost going from 0, 0 to 3, 3, like grid tile wise. Now, that also means that it kind of returns a thing called a pathing array, which is an array of points that the thing needs to move to get from point A to point B, right? Now, to store that, we're just going to create a new var, and it's going to just be called the path underscore array. And we're going to set that equal to, we're going to set the type of that as an array. And inside of the brackets here, or square brackets, we want to just set this as an array of vector 2i and set it to a new array, like so. Now, we're going to need to pull the ready function in, pass in there, and let's create a new function here, and this is just going to be for setting up the grid. So let's call that set up underscore a star underscore grid. It's not going to need any parameters, and it's definitely not going to need a return type, so we can just set that as void. And now we need to do some really simple setup. Now, a fun thing with Godot, of course, is you can just go and click on this, and it will show you how to do the setup correctly, which is this. This is basically the setup here. Now, that's what we're going to do. We're going to write a star grid dot region. So this is going to set up how large or what our region of the A star grid actually is. We're going to set that equal to a new, or equal to the tile map grid dot get underscore used rect. That's going to get every, or the size of the rectangle inside the tile map layer for every used tile that we've done. That makes it kind of a programmatic region. The next thing we want to do is grab the A star grid and use dot cell size. So we want to make sure we know how large our cells are. And we'll do the same thing, tile map grid dot tile set dot tile size, and that will give us the size of our tiles. The next thing you can do, this is entirely up to you, but I'm going to do this because I think it gives a more of a tower defense kind of feel. We can change the diagonal mode. Now, this basically says, can you move diagonally, yes or no? Default, it can move in all 8 directions, right? It can go up, down, left, right, and top left, top right, bottom left, bottom right. Now, we can turn that off, or we can turn that on, depending on how we want it to be. So if I just start writing here, you'll see diagonal mode always, at least one tile walkable, diagonal mode max, never, and only if no obstacles. Now, I like to do only if no obstacles, because that gives it this, if there is something in my way, I will not move diagonally. Like, say there are 2 blocks, and there are 2x2 grid, right? You have 1 block here, 1 here, 1 here, and 1 here. And the top right and the bottom left corners are non-walkable tiles. It will still cut through. Whereas with this one, it will make sure it never cuts through. But it will allow it to move kind of independently afterwards if there is nothing, or move diagonally if there are no obstructions. So now we just need to call the A-star grid dot update. And that will actually update our grid. So now our grid has been created. Now, there will be a fun little issue with this. I'm going to call this inside the ready function here. I'll hit Control S and save. I'm going to go back to main under 2D, and I'm just going to use Control Shift and A so I can instantiate a child for the Pathfinding manager. I'm going to put that up at the top, and I'm going to click play. Now, of course, we're going to have an error because guess what I forgot to do? Assign the tile map grid export. So let's go and do that. Let's click play one more time. And I said there's a problem, but it's not giving us any errors or any warnings or anything like that, right? It's just saying delta is never used under a process function that we're not actually touching. So what I'm going to do first is go back to the enemy spawner that we created, and I'm going to remove this print debug like so. We don't need to actually know what's going on in there, and that should allow us to not get spammed. Oh wait, no, we're still getting spammed. Why are we still getting spammed? Oh, that's why. Let's no longer get spammed on the enemy timer either. Awesome. So the next thing that we want to do here is back to our pathfinding manager. And I'm going to start iterating over a certain thing, and I'll kind of show you how it works. After that, by iterating, I mean I'm actually going to show you where this is kind of going wrong. I'm going to create an exported var. I'm just going to call this P for now. I'm going to set it of type packed scene. Set that equal to null. Now this is purely for testing purposes to show something off. You don't need to follow this. If you ever see me use variables like this, it's just a quick way of doing things. So we have a packed scene here. Under the Astar grid, what I'm going to do very quickly is just run a for loop. I'm going to go for I in the Astar grid dot region. Oh wait, no, I want to do the tile map grid dot region. Yeah, use rect dot size. There we go. And now what I want to do is go var new underscore p, set that equal to the enemy entity for now. Set that as an as p dot instantiate, and then I'm doing this wrong immediately. For y in tile map grid, this is a very dumb way of doing this, and I wouldn't recommend this in the future unless you plan on doing specific grid iteration. But we'll work with that when we actually get to it. Dot size dot y, that should do it. Is that gonna do it? Yeah. I need to not do that. I'm getting all of my hotkeys wrong today. I don't know why. Do I need to do the X and Y there? That's a good question. No, what? Oh, get used cells, that's why. That's wrong, being dumb. And we use .y.x. And now I just want to go and set new p dot position equal to a vector to I for the x and the y, and then we'll just do an add child for new p. So when I click play, this should break. And it's actually a null value, so it broke immediately because I didn't do the scene loading. Try again. So first issue we see here is, well, now it's put all of the children into this one square up here. So that's wrong, right? Something is wrong there. Now, the reason that's wrong is because this is a weird coordinate. This isn't technically the correct coordinate. Now, we can get the correct coordinate if we go and do times 64, which is the same size of our cells. What this will do is place them along the grid, right? Now, there is a problem with this, as you can probably see. Even though we are placing them in the top left corner of every square like so, it's not actually covering every square. In fact, some of the squares are cut off. This is all kind of oddly shaped and misplaced. Now, the reason for that is if we go to our 2D scene and we actually come and have a look up here, we can see that the 0, 0 coordinate, which is this square right here, is here. And this is exactly where our grid actually will always start when we iterate over it like this. It will always start 0, 0, so it will always start here. So even though this is x by x or x by y long in like the negative x and the positive x, it's only starting here. So it's going to kind of add this extra bit over here. So it's going to be off-centered. Now to fix that, we just go to our tile map layer, we grab our selection cursor, and we highlight all of our tiles, and then we just move them across like so. We click play, and now all of our tiles are mostly lined up. Now, there is another issue with this, right? Let me just center the camera a little bit. We don't want them to spawn in the top left corner. We want them to spawn in the center of the corner. So this is where it gets just a little bit weird. What we actually want to do here is, instead of timesing by 64, we want to grab the tile map grid dot map to local, and we want to click play, and that's it. It's done. It now sticks them in the dead center of every single tile. That way we're actually getting the correct tile. Now, the only reason I've done this is to show that our grid is now set up, right? This is a little testing thing so we can make sure that we know exactly what our grid is and our grid is sorted. So with that done, we can start modifying certain things. We know that our grid is getting set up correctly. Now, to do that, we're going to create a new function. It's going to be func, and we're going to call it update underscore terrain underscore movement underscore values. Now, what this is going to do is it's going to grab the movement values that we need to set on tiles, and it's going to allow the algorithm to actually, in a very smart way, choose what tiles it should walk on, or basically what tile is going to be the fastest or less costing to get from point A to point B. This is where the fun part of the algorithm kind of comes in, which means we actually need to go to our tile map layer. We need to come down to custom data layers, and oh yeah, we can remove the navigation layer. So let's remove the navigation layer. Let's come down to custom data layers. Let's add an element. We're just going to call this the movement underscore cost, and it's going to be of integer type. Now, a really fun thing to think about here, or a really good thing to keep in mind, is how the custom data layers get indexed. This is indexed from 0, of course, same with most things. So this is indexed in a normal array, so buildable is 0, movement cost is 1. That will come into play quite a lot, because the way you can kind of access these is you can call the name specifically under a string, or you can use an ID for it. And we're going to be using an ID because it's just a little bit cleaner and a little bit easier to do. So what we want to do here very quickly is go for I in the tile map grid dot get underscore used cells. So we're now grabbing every cell that we're using. Let me add some space. There we go. Also close the debugger real quick. Shrink this a little bit. So for I in tile map grid dot get used cells. So now what we're doing is getting every single cell we are using. So what I want to do here is I want to go if the tile map grid dot get underscore cell tile data, and then I want to pass in I, because that's the coordinate of the cell. That's what we're kind of looping over here. We're looping over the coordinates of the cell, and this takes in a coordinate to know exactly what cell it wants to get. So whatever cell is at I then want to go and get the underscore custom data by layer ID. I want to pass in the ID 1. Now I'm going to do this very quickly. I'm going to go, I want this to make sure it's not equal to 10. So if that custom data is not equal to 10, it needs to do a thing. I'm going to write pass so we can actually go and look at that. Go to the tile map, pull this up, let's actually go to tile set, there we go. Now we want to start painting some numbers on these. To do that, we're going to click paint, we're going to go to property editor, and movement cost. Now, I want to set this to 10 immediately, and I want to sit here and go, what tiles do I want to be at 10? Now, 10 is a very specific number for me. It doesn't need to be 10, it could be 3, it could be 5, it could be whatever you want. I just use 10 because it's a bit easier to see. This is going to be the, if it is 10 or above, you cannot walk there. This is a very quick and dirty way of just getting it to make points invalid for the algorithm to actually go to. And I'll show you why in a second. So what things do I not want them to be able to path through? Well, green tiles. I don't want them to be able to path through these specific green tiles. These tiles, I don't want them to path through those. And technically speaking, I don't want them to path through these corners either. So now what we want to do is go, okay, bump the cost all the way back down to 1. What tiles do I really want them to be able to stick to? Well, these lines here, these are the center lines that we use on our map, right? So I want these to be the lines that they actually choose. I want them to mostly try to stick to these so it's obvious where we're going. Now, we'll make this a kind of procedurally generated line in the future as like a little visual to apply, hey, this is where they're coming from, this is where they're going, and it will modify based on the algorithm as well. So the next thing I want to do is bump that movement cost up to 2, and these corners can be a 2, and this little square here can also be a 2, and that's it, we're done, right? We have set up the movement cost of all of our tiles. But let's go back to the script real quick. Now, what do we want to do if it is not equal to 10? Well, if it's not equal to 10, I want to grab the Astar grid. I want to use what's known, or what the function called set point weight scale. Now this is going to set the weight scale at the location, which in this case is I, and it's going to set it equal to the scale of that movement value that we actually put in the tiles. So we now need access to that, right? So let's go tile map grid dot get underscore cell underscore tile data, once again at I, and then dot get underscore used, or get custom data by layer ID, and we want to pass in 1. So that's going to basically make it easier to, well, that's going to set up our weight scales so they can actually pathfind through those points that we want to do, if it's not equal to 10. Now, what happens, if it is equal to 10, or greater than 10? Well, this is where an else comes in. For everything else that doesn't have a weight scale that is not equal to 10, well, what I can do here, which will be better, is greater than or equal to 10. Wait, sorry, we want, if it is less than or equal to 10, do the weight scale thing. If it's not less than or equal to 10, we just want to go astar dot set point solid at I, and we're just going to pass through true to make sure that point is set to solid, which basically means you cannot walk here. This is a very quick and simple way of setting up those weight scales. Now, after we call the update in setup astar grid, I want to call the update terrain movement values. And one thing that, this is one of those moments where you have to sit there and go, is this too long? Is this too weird to use? And yes, if you actually think about this, this is a really, really long line. Now, we can actually create a very quick helper function. And it's just going to be called get underscore cell underscore movement underscore cost. It's going to need a cell underscore position pass through. I can spell, there we go, a cell position pass through, and that's going to be a vector to I. And it's going to return an integer. Now, we just need to return whatever this line is, right? Sorry, whatever this line here is. And instead, we need to make sure we pass through 1, and instead of putting I through, we just need to grab the cell position. So that means what I can do here is on this line, I can just call that get cell movement cost, and I can pass through I there, and I can do the exact same right here, get cell movement cost, and pass through I there. So now we have a little helper function. It makes the code look just a little bit cleaner. It is a really nice little thing to do. And the final thing between the helper function and the update terrain movement values that we've done is we want to actually build a current path, right? So to do that, we're going to create a new function. It's going to be called get underscore valid underscore path. We're going to need a point to point, so we're going to need a starting position where we currently are. So let's put that through, start underscore position. That's going to be a vector to I. And we're also going to need an end underscore position. That's also going to be a vector to I. And now we want to kind of just do some things. The very first thing I want to always make sure to do is grab the path array and call .clear. We want to always pass back a path array that actually works, right? And I need to do this as well. Instead of a void return type, we actually want this to return an array of type vector to I. There we go. So what we're going to do here is we're going to populate this array, and we're going to return it from this function so it can be called anywhere else, right? This is the only function that should get interacted with from other scenes. So yeah, we want to always return that array. Now, every time this gets called, if we don't clear the array, that array will just keep building and building and building, and after the second call, well, technically after the first call, all of the paths will get jumbled together, and they will just start trying to follow every single point we've ever generated. And we don't want that, so we want to clear that array. And just as like a little, hey, just in case, let's just go and clear the path array here as well. Under the update terrain movement values. Not technically necessary, but hey, just a little safety check, just in case. So now what we want to do here is we want to do another for loop. And we want to grab basically the points between where we currently are and where we want to go. Now to do that, we just want to go for point, make this easy to read, in the astar grid dot get underscore point path. We want to pass through that start position and that end position, because that is what get point path does. It will return the actual grid of paths that we need to do. Now we're going to create a new variable here. This is something I like to do because I like to make sure things are centered. So I'm going to create a variable. I'm going to call this current point. I'm going to set it as a vector2i and set it equal to the point. This is a really fun visual way of doing this. And now what I want to do is grab that current point and I want to modify it, right? So the reason why I'm doing this is the original point doesn't get modified. The current point, however, does. Now that current point is going to have plus equals, and we want to add to it, right? We want to increment or increase it by the Astar grid dot cell size divided by 2 as a vector2i. So what this is going to do is it's basically going to, in our case, instead of 64, it's going to add 32 pixels to that point, which means what it's going to try is centering out the actual point where the path is. So instead of going to the top left corner of every grid or every cell that we're pointing at, it's going to go to the center of every cell. So now what we want to do is grab that path array that we set up originally, use dot append, and we want to pass through that current point. And then finally, outside of the for loop, we want to return the path array. So it's relatively clean, relatively simple code, and we're more or less done. That is basically all the pathfinding set up. Now we just need to actually allow our entity to start using this, right? So for that to happen, what we can do here is we can go back to our enemy entity script. And right here, we're going to add another export. And this export is going to be for the pathfinding underscore manager of type pathfinding manager. We'll set it equal to null. Now we're going to need to, under the ready function here, we want to set the path array, which we currently don't have. So let's go, and I thought I already added that. Let's go and set that up. Var path underscore array of type array vector2i. There we go. Set that equal to an empty array. So we want to set that path array equal to the pathfinding manager dot get valid point or get valid path. It's being done. Why is it being done? Did I not save this? I think I may have not saved that. Yep, I did not save that. There you go. We want to get the valid path and we want to pass through our global position. Now, if we just pass through just our global position, what we're going to get is a really weird grid. We actually want to put this into grid terms or grid positions. So to do that, we just divide that by 64. Our global position is now divided by 64, so we're now on a grid kind of step instead. After that, we want to grab the target position, which in this case will be a marker 2D. And we're going to write target pos dot position, and we want to divide that by 64 as well. So that's also in a grid step. So we now get our path immediately. To make sure that we are getting our path immediately, let's unfull screen this. Let's go back to main here. Not main, let's go to the enemy that we haven't added yet. So let's go Control Shift A, add an enemy entity. We'll add it at the very bottom here. Assign our pathfinding manager, and we're going to need to make a marker 2D. So let's do that real quick. Let's go Control A, we'll add a marker 2D to our main scene real quick. I'm going to put it at the endpoint here, which is just down here. There we go. And now we can go back to our enemy entity, target pos, marker 2D. Go back to our script. Yes, and now that we have our actual points that we want to move to inside of the pathfinding manager, we now need to create a new function here. So let's go func get underscore path underscore to underscore position. And now we just need to kind of iterate over our path and actually get it to run things. Now, very quickly, before I forget, because we all know that I will, we're going to set up the ready function. No, not the ready function, the process function for now. We don't really need the physics process for this. We are going to call move and slide. And just above move and slide, we're going to call that get path to position. So we know it's all ready set up and ready to go, and I'm not going to forget. So we need to do some checks. First, we need to go if the len, or length, of the path array is greater than 0, which it should be, right? If we have a valid path array, it should be. We need to set our direction, so we'll create a new var, call it direction. We'll set it of type vector2 that are equal to the global position dot direction to the path array, and then inside our brackets here we need to access that array and access the 0 point. Now we want to grab our velocity and set it equal to the direction times the movement speed that we created earlier. Now we just want to make sure that if our global position dot distance to the path array point that we actually want to modify, so in this point it will be 0, so path array 0, the one we're trying to walk towards, is less than or equal to 10 units, or in this case 10 pixels. We then want to grab that path array and we want to use dot, remove at, and pass through 0. So it's always going to basically hop through that point and remove it every time we get there. That way we're actually slowly incrementing that pathing array down to the point we get to our actual target, right? This will allow the full movement to happen. And now I'm just going to add a very, very quick else just outside of the if-len specific if that we have there. And I just want to set the velocity equal to vector2 dot 0. And now, if we have done everything correctly, this should work like a dream. Now, to test this, what we're going to do is, one, we are going to put our enemy entity right here. There we go, make sure we can see the guy. I'm going to hit play and it should do nothing. Oh, no, there we go, it basically skipped. And now it's following the path, and look at that. We now have valid pathfinding. So to test this, what we want to do is we are going to come down here, we're going to click play, and we're going to see what happens. Well, why is this breaking? Here's the thing, right? We don't want it to ever get to the point where it can pathfind on those green tiles. Now, the reason why it's actively breaking here is actually because these green tiles have a number associated to them. So if it is less than or equal to 10, oh sorry, where is it? Pathfinding, there we go. We set this up right here. If it is less than or equal to 10, do that. What we want here is less than 10 set point weight scales. So now if I click play, our guy doesn't move because he can't actually validly get a path from here to here. So that means they will never pathfind outside of their actual location. But I haven't actually shown you the coolest part of this yet. Yes, we get a little guy who can move along and he will always find the correct path from point A to point B. What this actually means here is we can come down to the tile map. We can actually start painting some fun tiles. So let's grab these green tiles here. Let's just add a few, right? Let's add one like this. Let's add another like this. Let's do that. Let's do this. Let's add a little trap right here. So if he walks down there, he'll get stuck. Let's do some more there, there, and there. Now, if I click play, what should happen is he'll start actually finding the correct path to the location. Now, this is just really useful. Not only is it useful for tower defense games, it is just really useful in general for a lot of games, but you now have pathfinding on your enemy. In the next part, we're going to actually go and add a bunch of spawning to this. We're going to link all of the things we've created over the last 2 episodes and actually get them spawning as a wave. We're going to set up wave data and a bunch of other fun things. But for now, I hope you've had a good time. Thank you for watching. I hope you're having a great day and a great game dev journey, and I'll see you in the next one.